All right, guys, next section about the limits. We are going to use the graphs to find the limits today. I call it our section 5.2. And so far we did two things. We looked at the end behavior, and that was mostly for the rational functions. You did this as a homework assignment. I will put the answers for the homework assignments, for the Monday homework assignments for the 5.1 at the end of this video, so you need to last till the end, or you can just slide to the end of the video and then pause there and the answers are going to be there. So limit the end behavior, we looked at the end behavior, but we also looked at what is happening at any value of x. So couple things today. We are going to look at the graphs. And my example number one, if you can copy the graph that looks like this, notice it is something. I am only saying that this is my function f of x. But what I am also saying is that there is an undefined situation going on here. And the point for x is equal to 3, we can assume that this is whatever value it looks like, 3. So the first question is just asking you for the value. So what is f of 3? Notice that this has nothing to do with the limits. So f of 3 for the value of the function, the y, is 3. Now what is the limit? So limit as x is approaching 3 of the function f of x. So remember yesterday we said, well, we need to check what is happening when we go from left hand side. So if the x values are getting closer to 3, what is the y value going to be? And then the same thing, what is happening from the left hand side? Oh, I am messing up the sides. This is left side, this is right side. So going from the right hand side, when we go towards 3, our limit is going to be, and let's assume that this is 1, is going to be equivalent to 1, and because they are the same from both left and right hand side, the limit exists. What is happening as x is approaching positive infinity? So limit as x is going towards positive infinity, what can we say about that? As x is going to positive infinity, we are going to say that this is not going to exist at this time. As x is approaching positive infinity, we'll say does not exist, because we do not have any of that y value that it is going to go towards. And the same thing will happen here, does not exist. You will see we'll talk about those a little bit more later on, but there's not a specific y that we would be going towards. All right, now we are going to go over an example that is going to be a little bit more difficult. So I am going to show you a graph. You can take a second to copy a graph that looks like this. And then we are going to try to answer questions that I wrote down. So a couple things that I want to say that might be difficult to see. What I do have here is an asymptote at a. I am not giving any number, I am just saying that this is a. So there's an asymptote. Remember, there's no value. Something is excluded from the domain of the function. There is some holes in the graph, so I see a hole right in here. There's a discontinuity, so there's a lot of stuff going on with this graph. At x is equal to a, the function is undefined. I already said that. And now let's see what I want to answer. So the first question, we want to say, what is f of 0? So f of 0 is, so the function, the value of the function when x is equal to 0 is equivalent to 1. Okay, so I want everybody to see this. There's a dot right in here. I hope you can see it. And the value of the function at that point is equal to 1. Now, what is the limit as x is approaching to 0? So now as x is approaching to 0 from the left hand side, we are somewhere here. And then the same thing from the right hand side, we are also somewhere here. It is somewhere in between -2 and -3. I think it's a little bit less than -2.5, let's say -2.4. And I want you to see, we talked about this a little bit yesterday, those two, they do not have to be the same. All right, what is the value, f of c? So c is right in here, and the value is equivalent to -3. But again, what is the limit as x is approaching c of the function f of x? So notice, as I am approaching c from the left-hand side, the value would have been, well, I think it's a little bit more than 2. But if I am approaching it from the other side, from the right-hand side, it would be equal to 0 or somewhere close to 0. So because they are not the same, we are going to say does not exist. Okay, so remember that in order for the limit at the point to exist, as we are approaching the point from both left and the right-hand side, it needs to be the same. All right, what is happening when we are looking for the value f of b? So I see that f of b is equivalent to 1. What about the limit as we are approaching b? Notice again, going from the left-hand side and the right-hand side, they would not be the same. So we are going to say that this does not exist. All right, let's see. Limit as the function is approaching positive infinity. So again, this is something we are going to discuss a little bit later, but the y would not be a specific number. We would be approaching a positive infinity, I would assume here, but for what we are doing right now, we are going to say does not exist. And as x approaches negative infinity, what is the function approaching? Well, it looks like the function is going to approach 0. Okay, so again, this is testing your limits. This requires a lot of knowledge, but again, you guys see that there's a lot of stuff happening and a lot of things to remember about. Well, I did put that what is happening at x is equal to 0. At x is equal to 0, there's a discontinuity. Discontinuity of the function. So that's something we can take a look at as well. But this is a really, really interesting example. You will have plenty of opportunity to practice those for homework. All right, I'm going to move my paper on something a little bit different. And I have an example where I want you to sketch a graph that has a limit at x is equal to 2, but the limit does not match the height of the function. Well, you can think about this for a second. Everybody could have a different answer and everybody could have a correct answer. We only have 2 restrictions. So we want to have a graph that has a limit at x is equal to 2, but that limit does not match the height of the function. So if this is, well, we can do whatever we want, 1, 2, 3, 4, 5. So if I want the limit to be 2, so I may put a dot in here. I am just going to make a linear function. Why not? But then the limit does not match the height of the function, so the value of the function, well, I'm going to put somewhere here. Notice this is true. Limit as x approaches for me 2 of this f of x is equal to 2, right? And then the value is equal to 5 based on my example. should probably put the 2 in here. All right, let's look at another example like this. This is something you may want to think about for a second. Maybe I should have used the different numbers, 2 and 2 for x and y. But again, if you think about this for a second, it will make sense. As x is approaching 2, the y value is equal to 2, but f of 2 is equivalent to 5. All right, we'll do another one. We are going to sketch a graph that is defined as at x is equal to -1, but the limit as x is approaching -1 does not exist. So -1, we want the function to be defined, but we want, as it approaches -1 from left and right hand side, to be different. Well, I can do something like this, and I can do something like this. And that's it, because limit as x approaches -1 of this f of x function does not exist, but the value f of -1 is equal to, let's say this is 2. Again, for this one, everybody could have a different answer, and everybody could have a correct answer. All right, that's it. You will have a lot of practice on this. Make sure you put it together. Make sure you understand what we are talking about. As you know, this is just the introduction to the limits, and of course, this is going to get a little bit more interesting and tricky. So now I am going to show the answers for the homework. Some of you reached out to me with some of the questions, and everybody basically decided, who I spoke to, that the questions were not difficult, but the way the questions were asked was tricky. So for that reason, notice here you were just asked to describe the end behavior. Those were rational functions, so we just took the highest coefficient, and that was our horizontal asymptote, and that was our limit. There was a typo in number 3. It should have been x to the power of 3, and if that's the case, the limit was 2. Notice we always have to take the matching coefficient, so it was 2/1. The next part of the homework was to just translate the following statements into the limit notation. You can take a look, and also while you are writing this down, see if it makes sense. See if the limit of e to the power of x as x approaches -infinity is really equal to 0. What does this mean? And then we use the limit notation to represent the following mathematical statement, and we came up with those 3 formulas. Again, take a look, check your answers. I will write the comments for you on your turned in homework assignment. Make sure you guys have a great day tomorrow.